Everybody, welcome back. I'm here right now with Jose, who's here to tell us all about performance testing from zero to hero with K6 and Azure. Jose is a cloud-focused software architect with Swiss Life, and I, for one, as I was telling him before the talk here, my first love is .NET, and I cannot wait to learn some more about what he's got to tell us. So go ahead, Jose.
Thank you, Bill. So hello, everybody. And let's go ahead. Who I am and why should you listen to me? My name is Jose Luis Latorre. My ID in Twitter is GOSLAT. That comes from the first and last name. And my GitHub is essentially the same, GOSLAT. I've been a 9-year Microsoft MVP. I'm not anymore at this moment. And I'm a software architect, that community lead, and also pushing forward everything about performance testing in Swiss Life at the moment. Also, I'm leading a small user group in Zurich, where I'm leading it and having fun. But for today, I'm going to talk about performance testing, why it's important, why you should do it, why you should use K6 is a very, very good option. And I will deliver you an introduction to K6. So after this talk, you should be able to implement very, very real life K6 performance testing scripts. And next, I will show you how to integrate K6 with Azure DevOps to put things in a perspective and integrate that with your build in a CI/CD pipeline. I'll talk about a template, but I'll leave that for later and give you some conclusions to take home. So let's get started. Why should you do performance testing? There are many, many reasons. Initially, the test pyramid seems complete, but also almost not too much people does performance testing. A lot of people are starting to do it, but it's not really widespread. And everybody believes that the pyramid, the test pyramid, this one is enough. I mean, you have at the base the unit test where you test that everything works as a unit, then some component or integration test that you test different things working together. And at the top, you have end-to-end tests or UI tests. And usually everybody thinks this is enough, but it is not. There is no performance here. Everything here is functional, but what about non-functional? What about testing the stress of a fully loaded database or several users together? And you will not know about that because you're testing for only one user until it happens. We all know Murphy lives, right? And performance tests are key to check real life conditions. They are essentially the only way, unless you want your customers to do your testing, which is not a good idea. You know what happened with the Node 7 fiasco. Some people were almost at the risk of losing their legs or their lives even. You don't want your software to explode in your customer hands. It does not leave a good impression, let's say that, right? And also it cost some money. To Samsung, it was $17 million. And for a company I was in, and that's why I put a lot of love in performance, it costed quite a bit. Just the mitigation costed $2 million in a defect that was detected like after 5 to 6 years after a project was developed. Suddenly they did more serious testing and discovered quite a few things. And the launch of the product was delayed. And well, there was more money lost there. This 2 million was just the one thing for some months and a full architect for like 1 year or more. And well, testing production, what can go wrong, right? Things may explode, like for example, with the Node 7. Well, and the question here, key question is, would you dare put a project in production having done just a single test? If you're into modern development, you would say, no way. But what if I tell you, probably you are doing that if you're not doing performance testing because all your tests are for a single user. What if you have 10 or 100 or 100,000 or 1 million users? Things change, right? You need to do that. You need to test that. And the main message is as close as you detect a test, the less it will cost. There is A lot of benefits in performance testing. It ensures that your systems are reliable, shows their brittleness, and verifies SLAs and non-functional requirements. As well, it saves money because as soon as you identify a defect, you can fix it. And that's really cheap. If you identify a defect as soon as they are introduced, that's simply, for a developer, it's amazing. And for the ones that have to pay, it's even better. And saves us from, well, have you ever deployed in a Friday? Guess what happened on Saturday and Sunday, right? What if you have tested, ensured that everything will work? You can have a very relaxed weekend, and that is worthless. And there's a lot of studies that show that the cost really skyrockets if you identify an issue in production. The close, you identify it as soon as it is introduced, either in the architecture or requirements or in code. It's relatively very, very low cost. The same thing that costed $2 million was a defect in the database design that was, well, transmigrated to all the code and the architecture. A similar defect some years later in a project I was detected as it was introduced. I was the test lead there, and it took 1 week to fix, not 1 year, but 1 week. So, and not one team, just one person. In that case, me. So that's a quite big difference in cost. So as said, performance testing is the best way to identify hidden, hard to tell, hard to fix issues. And I would even dare to say sometimes it's the only way. It will save you money, a lot of money, and save you stress. Now, I hope you are already convinced that performance tests are good, are the way to go. And now let's look at the tool, K6. What took me the decision to use it? First, I look at its performance. The performance is pretty good. It's pretty high compared to other solutions. It is open source. They have a version which is open source and has very good activity. It's code-based, so you can put your performance tests as code and put them along with your code, so the tests evolve as your code does. So that's a very good thing if you think in DevOps and CI/CD integration. It's easy to integrate in any pipeline. Sorry, and it has many outputs and integrations. K6 has been recently acquired by Grafana, so it's another thing because Grafana is also very deep into open source, and the community they have is amazing, and they are adding a lot more things that I'm not mentioning here. Also, I would say it's a very modern, so compared to some years ago, things have changed. So it's code-based, it's not based in a UI. You can do things with a UI, but what generates is always the same and consistent and backwards compatible. And the productivity, I'm showing it here. It's really, really good. They have a lot of releases, so it's really good. And the RPS versus memory is pretty good. RPS is requests per second, so it's very high. It's not the highest, but it's really high. But what really caught me the attention is the features that we will take a look at in a glance in a second. Now, we will take a look at how to get into K6. So when you start with the technology, you ask yourself, how do I begin? How does it work? How to simulate a user? How to verify that something is good or bad? You know, the 200, that the response you get is valid. How to do a fail, pass test, or even more. The key here is to simulate real world load. So let's get to it. Where to start? Of course, there's only one way, to a hello world. So let's see how it's done. So I'm jumping here. I hope it's big enough. I think it is for what I'm looking here. Perfect. So here is a hello world that, first of all, K6, you develop it with JavaScript. You use a scripting language here, and you have some models that you can load from K6, which is pretty modular. So you import HTTP first. If you want to do HTTP request, you import the sleep from K6 for simply sleeping. And here is what it's going to execute by default. So here I'm going to do a HTTP GET request on this URL, which is a test URL from K6 itself, and sleep 1 second. How does it look? So I should have here a command. I'm going to the proper directory. Yep. Then we have the K6 command, not K7. We put the space, we tell it we want to run, and then we put the name of the script, in this case, hello world, and then simply press enter. Here, let's look at what's happening in a bit of detail. We are seeing where it's executing. If it's executing in local, it can execute in the cloud if you use the commercial version, where you have a lot more functionalities. And the script is executing, and the output if you are pushing the data somewhere. Then you have the concept of scenarios that we are not going to cover. And you have what's BU. In this case, I'm doing one request, so it is created for us. BU stands for a virtual user, the virtual user you're simulating, and the running time and the amount of BUs it's using, and the iterations it has done. In this case, 1, because it's only one request. Then show some statistics on the data. The data received in kilobytes and kilobytes per second, data sent, and a lot of data on the HTTP requests. The important one is HTTP request duration. This one, where you see the average, the minimum, the median, and the maximum, and also percent of 90% or 95%, and some information more about iterations and BUs, which I mentioned it's virtual users. All right, that's easy. We did a hello world. We took a look at how the data display works and what does it mean. So next thing is, how do I simulate a user and verify? This is done with the concept of BUs that we just saw, the duration, checks, and options. So let's take a look. I have this other script, which now I'm doing another import, which is a check. Check is simply, I want to check something and show it on the UI, nothing more, nothing less. And then I'm exporting these options, which is a variable that we can put several elements of data that K6 will use. In this case, I'm telling it, now I want you to use 2 BUs, 2 virtual users, and I want you to take a duration of 5 seconds. And then I will do the same I did. I do a HTTP GET, I assign it to the result, and then I check the result. And I check that the status is 200, the HTTP status, and then that the duration, the R timings duration is under 500 milliseconds, and then I sleep 1 second. Let's run the thing. Now we can see here the progress, how it evolves, and the BUs at the moment that are being used. And at the end, we see the duration and the checks, and the rest is the same. We can see that it did 8 iterations in total during these 5 seconds, and everything looks green. So that starts to be a bit more serious. Then the question is, how do I do a pass-fail test? And before you say, hey, Jose, but you just did that, right, with the checks, and tell, no. A check is a check. It doesn't tell you that it failed or not. It just puts a mark on something that went well or did not went so well. What you need to do is called a threshold. Threshold is, okay, I want, for example, that all the checks or 90% of the checks pass, and then everything, all the tests will pass. How do we do that? Well, let's go back to the code. And we added a new element here to the options. And here we tell the threshold will pass if a percentage of 95% are under 200 milliseconds on the HTTP duration. And the checks, I want the rate to be bigger than 90%. So the rest is the same that the test that we saw before. And everything goes into options, a powerful element of K6. How does it run? Let's see. K6 space run space name of the script again. 5 views in this case. This was increased a bit. And we get here the marks for the 2 thresholds. So everything is a pass. So that's how you do a threshold. Next thing is how do you simulate a real world load? That's a pretty good question. You have one concept, which is stages. The stages are essentially how you change the load over time. So usually if you want to simulate a promotion that you do in a ticketing system and the users will come in a progressive, like a ramping up, you want them to grow over time and then maybe stabilize or even go higher or go lower to mimic your load on the day, or to mimic the kind of load that you want to simulate in your tests. You can do different kinds of tests. You can do basically a load test, which is, I want to see if the system can support the amount of users it will have. You can do a spike test that okay, I have 100 users per second, doing like, for example, in 1 minute, 100 requests. And then you want to do a spike of 100 more to see, will this kill the web server on my application, yes or no? Or you can do stress test. Stress test is to determine the maximum load of your systems. How much users can you hold until it breaks, essentially, or to see if does it scale properly. So that's different ways to use it. So let's take a look at stages. Have some code here. And of course, also in options. So I keep the thresholds. And here I don't have the views anymore because they go in the stages. I have 2 seconds where I have a target of 5 virtual users, 3 seconds with 10 virtual users, and 5 and 1. Again, so 10 seconds in total. And by default, it's doing ramping up and ramping down. The rest is essentially the same. So 6. Let's see how it works. We can see here, if you look where I have the mouse, it's ramping up and now it will start ramping down again to do exactly what I told it I wanted. Again, everything is green. And now I did 54 requests to the test endpoint with a total of 108 checks, 100 kilobytes, still not that much, but you can see that we can bring it to a lot of throughput if you want. Then we have another concept, which is scenarios. This allows us to map real life usage because at the moment we're doing the default task, but a user will not just do one thing. You will have several users. You have, for example, an API for ticketing. One user will be doing a registration. Other user will be purchasing a ticket. Other user may have like 20% modifying the ticket or other things in your website. So probably you want to simulate a real load based on the different scenarios and match them to real world usage, if you know it, of course. So scenarios, I have them here. This gets a bit more complicated. It's like a sub options that I can map to a real execution. So I map a list of objects, which I call scenarios, and each object, which is a scenario, I put exec, which is a function for the scenario that I will call. It's no longer the default function that I've been showing. Then I put executor. We will not cover that, but this is the way that I want K6 to execute the request. I want to put here when I want this to start, how many views, or in case of open model iterations, I want this because I can now work with virtual users or iterations, which is the amount of requests that I want to hit the server I'm testing with. And then the stages again. So it becomes a lot more complex, and you can mix and shake that as you want. So with one test, you can do a lot of things. Here, I don't have any more than full function, and I have this function for one scenario and another to get the context. And this looks like this. Okay, 6 again, and 0, 6 scenarios. Here, important thing is you have here detailed the summary of the scenarios, and here you can see how do they work and the views associated. Let's run it again, and now we focus on the evolution. So this seems to be starting before, and this one comes later. This is because I put in the code here that start time 3 seconds. So you can really do very advanced things. And the beauty of this is that you understand how it works at a glance. You don't have a declarative, extremely complicated code. So the way it's defined, to me, it's really easy to understand this. I really love how this is conceived. I've seen other tools that are also code-based, and I didn't use them, even they were a bit faster because of the syntax. But of course, the best solution is the one that you like the most, right? And this is how you do performance test with K6. Of course, there is more. And the documentation on K6 is great. So I recommend you go there and take a look to it. Next, I'll show you how to integrate it with the cloud, how to integrate it with Azure DevOps. So I have, if I can find it, yes, here. So the documentation here is really good. In K6 is k6.io. But what I'm going to take a look now is I have here a small project with a repository that I'll show you in a moment. Here I have a simply repository that doesn't do too much, except that I have a performance test here under the performance. This is based in what I will show later, which is the multi-scenario template, which is a scenario based for different kinds of execution of tests, load, stress test, and a soak test, and everything is already working and using the endpoints from K6. So they give me permissions to use them and put them here. And here I have an Azure pipeline. This pipeline, I have added it in the pipelines. Let me go there. I'm opening it, I'm going to edit so you can see the YAML code. And here, I'm only doing a very simple thing. I'm checking if the directory performance, that's where the test script is located, checks. And if it exists, then I set the variable performance to true. And then the next task that we will publish the build artifacts if the variable performance is true. And then it publish performance folder as performance test. That's it. Then I have a release that we can see is successful. And I take the output. And here I have what I call a smoke test, which I think is one thing that you can do after you have a build. You deploy it, and then you can do a small test. I have here agent job, which I take the latest of Ubuntu, and then I install K6. Just to check this code I'm showing here, if you go there, you go to the open source, you go to the download, you can install it in Linux, Mac, and Windows. This case is Linux because it's good and it goes really fast. And what I'm doing, I'm installing that in the build agent already. Nothing less. Then I'm doing K6 version just to check if it works. The installation before work, this should provide an output and be green. And last, I do a shakedown test with Azure pipelines, and I do what you saw already, K6 run and the script. And then I'm doing a -e token username, and then if you're familiar with Azure DevOps, this is a reference to a variable, which I'm passing a username, a password, the test I want to run, and the environment, because you usually have a test, staging, production, you know. How does it work? Well, you have here on the pipeline variables, environment to run, the test to run, which usually that's no secret at all. So I want to run the smoke test. I want to run it on the test environment, and the token password, I put it as a password, and this will be put into Azure Key Vault by default, so it's secure. So what means that doing this way, you have no secrets in your test script, which is a good thing, I believe. And also, if we want to look at how it went, succeeded, we can take a look at the logs and the shakedown test, the part of the execution. This is a bit more verbose. It's also good. And at the end, I get some custom statistics that I created, and a lot of checks and a lot of different thresholds here, and everything passed for this test. So that's how you integrate K6 with Azure DevOps. Couple of things here is what I show you is a multiple scenario, multiple test template, which is published. So you can get the code right now right here as one of the Swiss Life open source projects. This has the goal of accelerating performance testing adoption and learning how to use the template, and of course, to promote that everybody that uses it, if you want to add some additional functionality, you add it, and well, everybody benefits essentially, which is the goal of open source. And yeah, if you want to contribute it, and if you use it, please give it a star, make it a bit more, a bit better. And yeah, what more? This is under the scope of Swiss Lab Open Source, where I work at the moment, lucky to work there. We are investing heavily in open source, giving some time to develop open source. And here is the multi-scenario template. Here are the old examples I have shown, and even some more. And on this part, there are some README on how to get started, what everything is doing, a bit how to contribute. And here is the template, which I showed you quickly. It has a lot more things. So it has a handling of the arguments, a handling of the environments I want to run, creating some custom URLs with environment, and also some counters, custom counters and custom trends, some custom statistics, and then checking the execution type. And then what I'm doing, what you saw with the options, I'm adding that programmatically based on the execution type that you pass as parameters. So I will set dynamically the options here. So I'm adding several scenarios here. Backend read the scenario, backend flow, front-end scenario, and a GraphQL even. For whoever does GraphQL, there's an example how to do that, and way more. And a soak test. And at the end, I'm handling that and setting the options object with these execution options scenarios that I have defined before. And have some functions in here that can help about data formatting and debugging. And also some interesting examples. I'm jumping a bit more on the setup. Setup is a phase that happens right at the beginning of each virtual user. And here is where you can get a token or authenticate and do a login with the user, get a token to use it with all the other executions of a virtual user that you will have. So we can execute the login, get the token, and then pass as parameter to all the other executions that you saw before. So it's quite good for reusing. So I recommend, if you want to do that and you're convinced, to check it out and use it. It's pretty good. Anyway, essentially, this is what we are using as a base internally in the company to create more performance tests here. And that's mostly everything. As a takeaway, I would recommend you do performance testing, unless you want costly surprises and Murphy lives and, well, or lost weekends or additional stress. I'm really happy with K6 as a solution, so I'm not shy to showcase and tell, okay, it does what it promises, and it does it really well. And to tell you, if you do performance tests, do it since the beginning of the project. Of course, your project is already ongoing. Yeah, there's no other way, right? But if you are going to start a project and you know what is the SLA in terms of users and spike of users, try that. It will tell you a lot. And you may have to change architecture of your project because of that. And that is good because you can do that at the beginning and not later on and have to change a lot more things, which will cost you time and money. And of course, use the K6 template, and if you feel like it, contribute back to improve it.
Hey, I do have a question while we wait for the audience here, if they have any questions for you. First of all, after I was slacking a coworker as you were doing that, I'm like, why would we ever use JMeter ever again? But disregarding my thing about JMeter, but one of the questions I had is, how often when you are running these tests, that do you actually end up finding problems? Like, are these? I mean, is it depending on the application? Like, how often do you actually end up catching stuff? Would you say? Since you're using these internally.
How often are we using that? So at the moment, one of the things I recommend is before going to production or doing a release. That's one thing. And then doing what I show, a smoke test, like a small health test, right?
And how often do they end up catching any problems, would you say? Like, are they, like, have you found it valuable in catching problems before it hits production?
Yeah, it is.
Awesome.
It is quite valuable. So we found, for example, a strange problem with the containers that when we were deploying a new container, there was like a small period of 1 to 4 seconds where all the containers were not really responsive. And that was really, really hard to catch. That was one thing which now is fixed.
Nice. I guess give people one more second because I had one other question. Sorry. The ability to deploy to the cloud is really awesome. How well does this scale? Like, I've had to deal with systems that maybe we're expecting thousands, tens of thousands, even hundreds of requests per second. Is that kind of the nice thing with the cloud runners, is you can run multiple simultaneously?
You can do that. So you can do that with the commercial system. So that's given for you. That's really powerful. So if you use their commercial platform, you can even send, you can attack your API, your web from different parts of the world, even. So you can distribute the load globally, worldwide. And in the open source, you have the K6 operator that you can distribute your tests in different nodes of Kubernetes.
Well, Jose, thank you so much. I don't see any questions. As always, folks, you can always hop in the Zoom room afterwards if you want to get some more one-on-one time to ask about the K6 and all the rest. And I really appreciate the talk. Like I said, I found it immensely valuable personally. I really appreciate it. Thanks so much.
Thank you, Will, and have a nice day.